Hello everyone, welcome to another video. Today I want to start a new series and give you an introduction to the Gateway API in Kubernetes. In this first video I want to give you an introduction what the Gateway API is and how it differs from Ingress. Also, as you can see from the title, I will give my opinion if you still need Ingress, and if we do, what the future is going to be like. The plan for today is, first, I'm going to talk quickly about the Ingress, what it is, why it is useful, also what the downsides are. This will lead us to the Gateway API. This is kind of an evolution of the Ingress and will bring several advantages which were disadvantages with the Ingress. Then we're going to talk how the routing works in gateways. Then I'll give my opinion, Gateway versus Ingress. And in the end, I want to give you an introduction to the video series I've planned and what videos I want to publish over the next couple weeks. With this, let's get started and let's talk about how we can expose our pods to the internet or to our network. If you run the cluster on the cloud, then the easiest way is probably to have a service of type load balancer. Then you will get a public IP address and you can access your application. Another option would be to use the type node pod. This also gives you access to the service, therefore to the pods, but it's less common in the cloud. The next option would be to have an ingress. This could be an application like Nginx or Traffic. It's a single entry point to your cluster, and then you can route from the ingress to your services and therefore to your pods. And since we talk about the Gateway API, this is also a way how we can expose our applications. It's very similar to the ingress on the outside. So we have a single entry point to the cluster. We can configure the routing and access our applications this way. Now to dive a bit more into the details of the ingress. The reason why we want to use the ingress is to expose our pods to the outside world, mostly to the internet. And also if you want to have more features than if you want to use a load balancer type of the service. As you can imagine, if we expose our pods using the service load balancer type, then we just get a public IP address, but nothing else. Our customers won't go to our website or online shop with a public IP address. We don't have HTTPS, we don't have routing. There's so much missing of features which we need in a real world project. Therefore, the ingress allows us to have more features. One of them is that we have a single entry point to the cluster. The big advantage is that we have one object which we can configure, in this case the ingress, and then the developers can focus on developing the application and not on the infrastructure. Another advantage is that we have better routing. So we can do routing based on a path, on a URL, whatever we need. And one of my favorite features is we can automate the TLS certification and management with another Kubernetes object. It's called Cert Manager. And with this Cert Manager, we can tell it to create a certificate, for example, with Let's Encrypt, and the Cert Manager takes care of everything. Also, before the certificate expires, the Cert Manager just renews it. So we don't have to think about renewing our certificates to install them. Everything is done automatically. Since we're using TLS, we can also have TLS termination on our ingress. This means we have a TLS or HTTPS connection to our ingress controller, and from there we can have HTTP to our pods and applications. For the ingress, there are many popular ingress controller. The biggest ones are probably Traffic and Nginx. And if you use the cloud, in my case I use Azure, we have the Application Gateway Ingress Controller. That's a managed feature by Azure, and it gives us even more features compared to the basic Traffic or Nginx options. Then the way how the routing works is actually quite simple. So we can call our domain. It can be with TLS, this means HTTPS or HTTP. Then if you're using Azure, we land at the Azure Load Balancer. This redirects the request to the ingress controller. The ingress controller forwards it to the service, and the service forwards it to our pods. Ingress is great, but as with everything, it comes with a couple downsides. One of the probably bigger downsides is that it has a lot of control how the traffic is routed. This sounds great in the first moment, but the problem is it can be a security problem because you have everything in one place, and also you have a single point of failure. So if somebody misconfigures something, nothing will work. And the probably biggest downside is that it uses annotations. And these annotations are unique to the Ingress controller you're using. For example, if you use Nginx, you have different annotations than if you use Traffic. And this leads to a vendor login. This means you will need some work to move from one Ingress controller to the other one. Another downside is that the TLS secrets need to be in the same namespace as the Ingress and as your pods. This means you can't have any connection in between the namespaces. With Gateway API, just as a spoiler, it will be possible. Another downside is that it doesn't support traffic policies. This means we just don't have this feature. Also, we don't have modularity. I think that's a bigger problem because everything is just in one Ingress object. Most, if not all, of these downsides have been addressed in the Gateway API, which has been announced in 2023. This means I'm already late to the party, but there's so many new features in Kubernetes all the time, which makes it a bit hard to keep up, and better late than never. Now, before we go into the Gateway API, let's take a look at the Ingress and the Ingress controller so you can see how the configuration looks like. Here we have the Ingress controller, and as you can see, it's quite interesting that the type is service. It's not Ingress or Ingress controller. Then we have a name. We have a whole bunch of labels and annotations down here. And this is what I said before. We have these labels for a specific vendor. In this case, we can already see that we're using Nginx because it's all over the place. And this also means if you want to switch to Traffic or something else, we have to update all of this. If we scroll a bit further down, we define a couple ports. This should be quite self-explanatory. We have HTTP with HTTPS, port 80 and 443. This means we are listening to both. Then if we scroll further down, then we have here a couple IP addresses of the cluster, even more configuration, and then on the bottom here, we have a public IP address. So even if you've never seen it, it's not too hard to understand, but this file only has around 50 lines, so it's as simple as it can be. If you have a bigger team, maybe even a couple teams, then it can get quite complicated because everything is inside this one file. Additionally to the Ingress controller, you also need an Ingress object, and this is for the application itself. So now we can see here it's of type Ingress. It's for an application named Customer API prod. Then again, we have a bunch labels and annotations. So it's again the name, what cert manager we use. In this case, I'm using Let's Encrypt to create TLS certificates. And also we have here the reference to the Ingress class, which is again Nginx. Then if you scroll a bit further down, we can see here we have TLS configured for my domain. Then we have the routing rules. In this case, I'm only listening to port 80 and I route everything I have to this customer API. Lastly, we have here the IP address of the Ingress. So in this case, it's different than the one we have seen before because I think I took the screenshot at different times, and in this in between, the IP address might have been changed. This also shows a downside of IP addresses. It's possible that IP addresses change, and it would be better to have a DNS name or CNAME. So we'll see later in the gateway that we will have exactly this. We don't have to rely on IP address anymore. With this very quick overview of the Ingress, now let's switch back to the presentation and take a look at the Gateway API. All right, let's talk about the Gateway API. As I said before, one downside with Ingress is that everything is in one place. A big advantage of the Gateway API is that the components are modular and they're split into multiple parts. So we can use whatever part we want or need, and it makes it easier to configure many or several small files over one gigantic one. Then similar to the Ingress, we have a gateway class, and this gateway class configures what proxy we want to use. This could be, for example, Nginx or Traffic like before, or we can also use one of our cloud providers. This is similar to the Ingress class we have in Ingress. Since I'm using Azure, I will use the Azure provided one, which means I can easily install it, and then I can just say I want to use Azure. The way a request works with the Gateway API is also very similar to the one in the Ingress. So we can have a request, can be HTTPS or HTTP. So in this case, it's HTTPS and it goes to our gateway. Then this gateway takes care of the TLS termination because it has a reference to the TLS certificate. The gateway also has a reference to the gateway class. This means the gateway knows which object it should use to process the request. Then what's new is this root object. That's a separate object that defines how we want to route our traffic. This means we can configure what port, what protocol, and we're going to look into the details more in a minute. But with this, we have our own object and we can say redirect or route the request from the gateway to my specific service, and then the service takes care of it to redirect it to one of the pods. Then, like with the Ingress, very similar, our gateway contains listeners. What's interesting is we can have multiple listeners on the same port. This means if you have two applications, let's say application 1 and 2, then both of these applications can listen on the port 443 for HTTPS. The only difference is that we reference a different TLS certificate. As I just mentioned, the gateway takes care of the management of the certificates. So once we have created our certificate, we can just reference it in the gateway, and the gateway takes care of, for example, TLS termination. The gateway can also do backend TLS, or I can even configure MTLS. This means our client sends a certificate to the gateway verifies it, and then if you have also TLS in the backend, re-encrypts the connection and sends an encrypted connection to the backend. The gateway in general is quite amazing, I think, and it's a very great improvement. But what's especially great is that it can be namespaced. This means it doesn't matter in what namespace the objects are. You can reference them over different namespaces, which makes it way easier to have a clean management. For example, you can have a namespace for infrastructure, where you have all your gateway objects, everything you need for that. And then you can reference, for example, the secrets or TLS certificates in a different namespace, or your applications that are in another namespace. Then I also said this, that we have the gateway class, which is basically a blueprint and tells the gateway what object or what service it should use to process the requests. This gateway class is global. This means it doesn't matter in what namespace it is, we just reference it. And if it's in a different namespace than a gateway, then we only have to provide the name of the namespace and it will work. So after all this, it can be quite complicated. For me, looking into this was one of the most complicated things I've done, I think. But after working with it for a bit, it becomes quite easy actually. So now let's switch over to Visual Studio Code again, and let's take a look at one of the example gateways. Here in our gateway file, we can see it's of type gateway. Then we have a couple annotations, even though I said before we don't need them. But what we can see here is the first two are Azure. This means Azure related. So if you have an on-premise one, you won't need this. And the last one is for the cert manager. This is because I tell the gateway to automatically create TLS certificates if needed. Next, we have here our reference to the gateway class. We just provide the name and it will work. Then we have our listeners. So first we have an HTTP listener on port 80. Also what we can see here, we allow it from all namespaces. That's what I said before with it's namespaced. This means we can send requests to specific namespaces or we can have them in all. Next up, we have our HTTPS listener. What's different there is that we also have a reference to our TLS certificate. In this case, we provide the name of the certificate down here. And since it's in a different namespace, we also provide the namespace down here. Then the same, again, we have port 443 for HTTPS. We just have a different name for this listener. We have here a different host name as well as a different secret name, but the same namespace. This means our gateway is listening on port 80 for all requests and on port 443 for the Nginx URL as well as for the traffic URL. Don't worry if it's quite complicated right now. I will have multiple demos later in the upcoming videos and then everything will be clear. For now, let's switch back to the presentation and continue with a bit more of theory and how the routing works. Now let's talk about the routing in the gateway. As you have seen, we can have our listener that listens on different ports or the same ports if we have a different configuration, but we can also listen for different protocols. So we have seen HTTP and HTTPS, but we can also use TLS, for example, if we have an MTLS connection, as well as TCP and UDP. And what I forgot here on the slide is we can also listen for a gRPC connection. Also, as we have seen that the gateway can reference the TLS certificate, this can be either in the same namespace or in a different namespace. If it's in a different namespace, then you also have to provide an additional object. I think it's called reference grant. This gives the permission for the gateway to access the secret, since the request comes from a different namespace. This is just a small configuration, but in general, it's no problem at all, no matter where your secret or TLS certificate is located. Then as we have seen, we can configure our routes, which we allow, for example, to access the traffic URL or the Nginx URL. Then we can have MTLS configuration. This means our client sends a certificate to the gateway verifies it, and then forwards the request to our services. Or I can also re-encrypt it and then send it encrypted to our service and then to our pods. Then what we also have seen is the routes object. These routes configure how we handle the traffic. For example, we can have waits and therefore we can have load balancing. With these waits, we can split the traffic. If you've never seen this, it might sound complicated, but I will show you in a demo. It's super easy and very useful. Then what's great about the routes is it uses standards. It doesn't use any annotations. This means it does not matter what gateway class you're using. If you use Nginx, traffic, the cloud, something completely different, it does not matter. It will work and you will be able to switch without any problems between them. Then for the routes, we have the same protocols as before. This means HTTPS and HTTP, TCP and UDP, gRPC, and also TLS. So it's the same protocols we have heard before. For the routing, we have different options how we can route our requests. So the first one, the most simple one, is path. This means, for example, if we have /online shop, we can redirect or route to our online shop. If we have /management UI, we can route to a completely different application that is for the management of our online shop. Then with the header, we can also route the requests depending on the header. This can be useful, especially if you have different front ends depending on the user agent. So if it's from a mobile, you might have a different application than if it's from a desktop. Then we can also route based on the query parameter. Then what's very cool is depending on the HTTP method. This means we can have different applications for example, a GET request and a POST request. Additionally, we can also redirect the requests. So if a customer calls an old URL, we can redirect it to the new URL and our customer will be able to access our website and they won't get an error message. Now let's take a quick look at the routes. Again, I have a couple videos about this planned for later, but just so you can see how it looks like, let's switch over to Visual Studio Code and let's take a look. Here in Visual Studio, as you can see, I have an HTTP route. This means I'm routing HTTP traffic. Here we have a reference to our gateway. So we reference the name and the namespace it is in. It does not matter if it's a different namespace or not. As you can see here, the namespace of the route is a different one. Then for the rules, we have here a couple of rules. The first one is for the path. This means if this rule matches, in this case, if the prefix of the path is /routing, then it will redirect to the application named routing app name1. Or to be more specific, what's in this variable. Next, we have the header, and it works more or less the same. So if the header equals routing, but also if the path equals /routing, then in this case, we route to the application number 2. And with this, we can go quite crazy and complicated. We can have multiple combinations. We can also use regex, what we're going to see in the demo. And with this, we can control what requests should go to which backend. Now let's go back to the presentation and let's talk about Ingress versus Gateway API. Now let's talk about my opinion about the Gateway API and the Ingress. So I think this presentation was quite positive for the Gateway API, not that positive for the Ingress. But I don't think that the Gateway API will replace the Ingress, only in a bit more niche use cases. The reason why I think this is that the Ingress is super easy to manage. And if you already have a working Ingress and don't have any problems, there's no reason why you would replace it. Especially if you're a small team. For example, if you're one team that runs your own cluster and it works, then I don't see a reason to change it to the Gateway API. Where it might be useful is if you have a big company or department with multiple teams. For example, if you have an infrastructure team, a security team, compliance team, multiple development teams, then it might make sense to split it up and use the gateway. Also, obviously, if you have problems with the Ingress, if it doesn't fulfill your requirements, the Gateway API might be the better solution. For myself, I will use the Gateway API for now. So my demos before all used an Ingress, so I'm going to move this over to the Gateway API. But the main reason why I do this, it's the new shiny thing. And as a developer, I love shiny things. And so it's exciting to play with something new. There's no functional reason why I switch over to the Gateway API. Another reason I have to admit is I never dove deep into the Ingress. So when I had a problem, it was always a pain for me to figure out what the problem was because I wasn't an expert in it. With the Gateway API, I spent the last 1.5 to 2 weeks playing around with it, and for me it seems quite easy once you understood it, and I feel confident that I can fix all the problems I have with it. But in general, to answer the question if Ingress is dead, I would say no. The Ingress will stay, it will continue to exist. So I don't think that the Gateway API is an Ingress version 2 that will just replace the old Ingress, but I'm excited to see where the journey will go. In the end, I wouldn't be surprised if in 5 years we still have both around. The last thing I want to talk about is the Gateway API and Azure. I use Azure only. I don't know about AWS or GCP, but I would guess it's very similar if you use any of the cloud providers. So in Azure, we have the application gateway for containers. This is like the application gateway, but specifically designed for the Gateway API, and it brings additional features over the normal implementation. For example, we have advanced health checks. And also, since it's from Azure, it's more tailored towards Azure. So if you're using Azure for your applications, it might be worth to take a look into it. And also in the next video, I'm going to show you how you can set it up. Then what might be great is the web support, the web application firewall. This is a feature that's in preview right now, and I tried it out and it did not work at all. And also the documentation is horrible. After I read the documentation, I had more questions than before. So I've prepared a video for it, but we'll see if it works or not. Even if it still does not work, when the time comes to publish the video, I will publish it anyway, and maybe it helps one of you out there to implement it yourself. The last advantage of using the application gateway for containers is, again, an Azure feature. So Azure takes care of the scaling. So we have auto scaling, we have high availability, and it should be just a nice addition. With this said, I mentioned a couple times that I want to start a new series, and this is the first video about the series. Just an introduction of the Gateway API and a comparison with the Ingress. In next week's video, I will going to show you how we can use the Azure Application Gateway for Container to set up the Gateway API and everything we need on a new AKS cluster. Then I'm going to show you how we can host multiple applications and access them through our Gateway API. And then I'm going to show you how we can configure our DNS, especially how we can configure it automatically, that our DNS points to the host name of the gateway. This is necessary because I want to configure TLS, and we need our own DNS for the TLS configuration. After the setup, the next 3 videos are going to be my favorites, and I hope for you too the most exciting one. In the first one, we're going to install the Cert Manager, and I'm going to show you how we can automatically create TLS certificates for your application. They are free, fully automated, and it's just an amazing feature of Kubernetes. After this, I'm going to show you how we can create wildcard certificates. This is a bit different from specific certificates because we have to configure that the Cert Manager can access our DNS. We can set this up with managed identities in Azure. This means we don't have a password or a username, and everything will be automated once it's done. Then the third video is going to be a combination of everything we have configured before. So I'm going to show you how we can create a pull request deployment. This means I develop a new feature, create a pull request, and during that pull request, I create a complete new environment. This means a new namespace with all the dependencies. I deploy my application there. I create a TLS certificate, and I can access it with a totally valid certificate over the internet. This allows me to test it the same way I would test or access the production environment. After we're done with the pull request, we delete everything, and it is like it has never existed. This means we don't need any extra resources. All of this will be automated. So after all these exciting videos, I have a couple maybe less exciting but still very relevant videos. The first one is going to be about how we can implement path, query, and header routing. This means we can configure how we can route our requests and to which backend we route them. After this, we continue a bit more with the routing. So I'm going to show you how we can do URL rewrites and redirects, how it looks like for the clients, and why we do this. And the last topic about routing will be traffic splitting. This means we implement traffic splitting, and this will allow us to have canary deployments as well as API deployments. Since I'm using Azure, I'm also going to show you how you can use Azure for monitoring. This means we are going to monitor our AKS cluster. This also includes our gateway, and I'm going to use Prometheus and Grafana. In my case, it's going to be Microsoft hosted or Azure hosted, but you could use your own Prometheus and Grafana instance if you're not using Azure. Then the last video will be about the WAF, the Web Application Firewall. And I've said before, it's a preview feature. When I tried it, it didn't work. But by the time the video is to be released, maybe it works then. If it doesn't work, I will still publish it and tell you and show you what I did, how I think it should be implemented, and maybe together with one of the comments, we can figure out what the problem is. Then right before I started recording this video, I was thinking about a couple bonus videos. So especially I want to create a video afterwards where I show you how we can use the Gateway API without Azure. This means we just have a Kubernetes cluster and then we install the Gateway API ourselves. Lastly, if you have any questions, any topics you want me to discuss, feel free to write a comment and I will make a video about the topic as long as the Gateway API is involved. And with this is everything I wanted to show you for today. I hope it gave you a quick overview of the Gateway API, how it compares to the Ingress. And in the next week, we're going to dive into the terminal, create a new Kubernetes cluster, and then also deploy our first Gateway API. If you're interested in this kind of video, if you like them, I would highly appreciate if you could like the video. And also, if you're interested in the topics, subscribe so you'll get a notification every time I publish a new video about Kubernetes and the Gateway API. And with this, I hope to see you next week where we implement everything I told you today.